have another equals ratio. Are you not going to do it there this time?
Can't see the back of it, so I don't know how much to zoom in.
Oh, okay. Alright. Alright, so on the vocabulary, I'm going to make, this is going to be simpler when I explain it. Okay? So don't worry about the vocab. Because again, this part should be down to here. I don't know what I did. I must have been tired at that point in time. No, I wasn't asleep because it got done, but I don't know what I was doing. Okay, so we're going to talk today about percent of change and percent of increase, percent of decrease. Okay? Now, it says one way to describe a change in quantities is to use percent of change. A lot of times they'll use percent of change when we're talking about stocks, when we're talking about price increases or decreases. When the price of gas goes up, what percent did it go up? Okay, we rarely talk about the percent that it goes down. Okay, so what we're talking about here is not just the amount that something changes, but what the actual percentage of that amount that changes. Okay, so all the percent of changes it's a ratio that compares the change in quantity to the original amount. Okay, so we've got percent of change. And remember, that means change in algebra. The triangle means change in algebra. Okay? In geometry it means triangle. But not in algebra. Okay, so the percent of change equals the amount of change divided by the original amount. Okay? Now, if you look at the bottom in the notes on your paper, it says the amount of change is always a positive number. Okay? Never negative. Alright? The only thing that differentiates between if it's going to go up or down is when we write the word increase or decrease at the end. Okay? So, that is a percent of change. Now, let's talk about specifically the percent of increase and the percent of decrease. Okay? So, if we talk about the percent of increase of a number, basically we're talking about, let's say that you go to the store one day and you buy a candy bar that costs 50 cents. Okay? You go back a week later, and all of a sudden it is $2.75. We're not going to jump that high. Okay? But this happens, yeah, that's true. Okay, so this was the original amount a week ago. This is the new amount. Did that go up or down? It went up. So we are going to find a percent of increase. Okay? When you are looking at percent of change, all you want to do is take the bigger number, which in this case is the new amount, and subtract the smaller number, which is, in this case, the old amount. Okay? So the amount of change in this, we went from 50 to 75 cents. So what was the amount of change? A quarter, 25 cents, which is 75 cents minus 50 cents. Okay? Now, in our percent of change, we always put it over the original amount. Always, 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 always. Not the biggest number, always the original amount. What was it originally? 50 cents. 50. So, we have the amount of change divided by the original amount. So we have 25 cents divided by 50 cents, which is what? Huh? What is it? Huh? 0.5? Okay, but what are we finding? So, is this our answer? No. Correct. move our decimal point 2 places to the right and add a percent sign. That is the percent of change, but now we need to go back to our problem and say, okay, it started here and ended here. Did it go up or down? It went up, so this is a 50% increase. If you take half of the original amount and add it to it, you get the new amount. That's what it means by 50% increase. Okay? If it was a 100% increase, what would your new amount be? $1. You doubled your amount. You took 100% of the original and added it back to it. You took 50 cents, you took 100% of it, you added it on, and your new amount would be $1. Highway robbery. Okay? Does that make sense? Okay. Next, decrease. Notice.
You have to ask it.
No. It's the same. No. It's the same.
Just write decrease instead of increase.
Alright, so this was a candy bar.
It was $2.
Alright, now we are going to shop and we're going to get a shirt. And the original amount was $20 and now it is $18. We got a sale.
It went
So, what is the amount of change on this shirt? $2. Which big number minus small number? So we have a $2 amount of change. What is the original amount? 20. Here's your original amount. That goes on the bottom. Alright, so what is $2 divided by $20? 0.1. Is that my answer?
No.
No.
you put it 2 to the right and you get a percent.
What do you get?
10%.
Okay, now are you finished?
Write the arrow down.
Correct, because we went from 20 to 18, so we did what?
You gotta write the arrow.
Decrease.
Can we just put it down?
I'm fine with the down arrow.
Yeah.
Probably if you were on the benchmark or something like that, you better write out decrease or increase. They may, you never know how picky they're going to be. You take 2 divided by 20.
Alright, that looks a lot easier.
Yes.
Well, and the reason why I have it written on there like that is because the first equation says percent of change equals the amount of change over the original amount, which is true. But a lot of people may say, well, okay, well, what is the amount of change? Well, the amount of change is just the new amount minus the original amount. The second equation is just explaining the first one. So it's not two different equations. It's just explaining the first one. Okay? Alright, but just remember, like I said, you might want to just go ahead and cross those things out because I messed that up. Look at it this way. Percent of change equals amount of change over the original amount. And the amount of change is just taking the biggest number and subtracting the smallest number because the percent of change, or the amount of change is always positive. The only thing that distinguishes between if it's an increase or decrease is this arrow or the INC or the DEC. Okay? Alright, it says also an increase of over 100% means that the item or amount more than doubled. And don't forget to change all of your answers to percents. Don't leave it as a decimal.
So if it did double, would it be like 110?
Well, if it doubles, it's 100%. But if it more than doubles, like, you know, there have been times before when you've gotten, like if this went from, instead of being 50 cents to $1.50, that's more than double.
So
It's 150%. Right.
yes.
Okay, questions on that? Alright, let's look at a couple then. Let's look at number 2 on page 352. Right, now I didn't read this very well, and I didn't listen very well in the last class. So, we're going to do this the correct way this time. It says the cost of 2 different shelf stereo systems are decreased by $10. The original costs were $90 and $60 respectively, without calculating which had a greater percent of decrease and why.
The 60%.
It's number 2 on page 352. Do what?
60 because it's a smaller number, and the intervals are much smaller. Like
Exactly.
23.
If you've got a $90 stereo system and you take $10 away from it, and you have a $60 stereo system and you take $10 away from it, what have you taken more? The $10, what does it affect more, the $60 system or the $90? It affects the $60 a lot, because you're taking quite a bit of money away from that $60 system. A lot more than the $90. Okay? Good job. So the greater percent of decrease, huh?
But you're taking the same amount of money away from both of them.
You are, but you are decreasing the $60 stereo system a lot more percent-wise than you are the $90 system, because you have less money to take that $10 away from. So, amount-wise, they are the exact same. Percent-wise, the $60 system, it's got a bigger percent of decrease. Okay?
Whoa.
Don't worry about it. Okay. Let's look at number 4. First thing, tell me, is that going to be an increase or decrease? Decrease. Number 4. Number 5.
Whoa.
Increase or decrease? Increase. Number 6. Increase. Number 7. Increase. 8. Decrease. 9. Increase. Okay? Does anybody not see where we're getting that? If it starts out originally at a certain amount and it goes up, you have increase. That is a percent of increase. If you start out at a certain amount and the new price goes down, you have decreased. Okay, so number 11, is that an increase or decrease? Increase. 12. Everyone participate, please.
Increase.
12. Increase. 13.
Decrease.
Good. 14.
Increase.
Good. 15.
Decrease.
Good. 16.
Decrease.
17.
Increase.
Oh, what? Decrease.
Oh, decrease.
You went from 125 to 87. That is a decrease. 18. Decrease. 19. Yes. 20. Yes. 21. Yes. 22. Good. Okay. So let's do one.
Okay.
I gave you the increase or decrease, but we did not do the problem. You have to show your work. Here's what you have to show. Okay? Amount of change over original amount. Okay? Now, you either have to write this out every time, or you can write down the bigger number minus the smaller number. So let's say on number 4, the original was 30, the new is 24. So I can either write this or I can write this. What's the original? 30? Divided by 30. So you can either do this and then say, okay, in your head, because you can do it in your head, or on the calculator, 30 minus 24 is 6, divided by the original amount, which is 30.
So you can do either one.
Either one. You can either do it this way and then go ahead, because a lot of you are going to be able to look at that and go, okay, that's the amount of change on that is 6. I'm not going to make you do this and then this and then. Okay, either write this down. The amount of change is 6 over the original amount is 30. 6 divided by 30 is what? That's 1/5. So that's 0.2. Okay, which is 20%. That would be that problem. Or you could write down, instead of writing the actual equation, you can write down the biggest number minus the smallest number divided by the original amount. Not the biggest number, the original amount. So, then you get 6 over 30, which equals 0.2, which equals 20%. Either way,
This really is not that.
mm,
Why you gotta make it look small? I know.
I put that because it was in the book.
You wrote all that and I was just like, oh my gosh.
I put it because it was in the book.
I was like, oh my gosh,
Okay.
I'm so much.
And all of that is in the book, it's just in the wrong spot. I don't know what happened with that. And that is definitely my fault, but I don't know. Those are all true,
I figured out.
I just don't know what happened.
That's
That's okay, we're gonna keep going. Alright, number, what this is an increase or a decrease? Increase or decrease?
That's it. It's like
Decrease.
Decrease. Or you can do this, okay? Questions on that? Alright, what about 12? What am I writing down?
You're gonna write,
Okay, right, amount of change.
Amount of triangle.
oh,
Direct triangle. And then put it over.
Over what?
Amount.
Okay, and then what was your part?
140, minus 100, divided by 100.
Good, because what was the original amount?
100.
100, not 140, 100. Okay, so what is 140 minus 100?
40.
Over. Okay, this is the same thing as 4 over 10, which is 4/10, right?
And that's 40%.
Which is, or actually, I guess it was 40 over 100, so that's automatically 40%. And what is this, increase or decrease? What's that? Increase. Alright, now, what about number 29?
Hey, that's the answer.
Oh wait, I forgot, you guys are having to do those. Okay, what about number 23? I know you have to do them, but we need to talk about them because it gets kind of confusing with some people. Last class was kind of confused. You have to read the bold print, because if you don't read the bold print, you don't get all the information. You're doubling the length, the length of the sides. So, what do I do to find the percent of increase in the perimeter? What am I going to do?
I know. The original amount could be 12.
Could we just add?
What do you mean the original one? Huh?
Could we just add the size?
Yeah, we have to find the perimeter, right, of the original rectangle, correct? Because if we're going to find the percent of increase in the perimeter, first thing we got to know is the original amount. We have to know the original perimeter of that rectangle, right? Then, don't say, we're not going to actually do it, we're just going to talk through it. Then what do we do? But how do we find the amount of increase? We know the original perimeter, what would you say, Chloe?
You have to
Square the way it looks.
Right, but how? What are we going to compare that to? What is going to be the second one though? The double one, right. So we've got to double the length of these sides and then find the perimeter of that, and that's our new size. So then we take the original and the new and we subtract them. Okay? So you have to find the perimeter of the old, you got to find the perimeter of the new, and then you can find the amount of change. Okay? Same thing goes with 24. Find the percent of increase in the area. You have to find the area first of that rectangle, of the original rectangle. Then double the sides, and find the area of that rectangle. Okay? And then you can find the amount of change and the percent of increase. Okay?
Yes, ma'am.
Questions on any of that? Pretty simple, right? Yes, you can start. You've got 10 minutes. You should be able to get finished.
I'm on 18.
That doesn't make me happy. font.